Okay, let's start the class. So whatever we have covered so far, is there any question regarding these topics? There is no question. So today we are going to discuss about the register that is made of several flip-flops. So as you can see, there are three registers, 1, 2 and 3, which can store 1 bit each. And now if you want to um, have this data as an output of another flip-flop, so what you can do, suppose we are considering the data stored in this flip-flop is 101. Now this is your D flip-flop, and the pulse that is provided here, is it a positive edge triggering or negative edge triggering?
Positive.
Positive. So meaning that when you have a pulse like this, and it will get the positive path edge, what will happen, whatever is the input of this flip-flop, the output will be the same as the input, right? So
Yes, sir.
output should be 1 when
One.
it gets the positive edge. Similarly, the output of this flip-flop will be the input of that flip-flop. So whenever it gets the positive edge, the output of this flip-flop will be 0. Similarly, for the third D flip-flop, the output of this flip-flop will be 1. So whatever is stored in your register using a flip-flop, in this case this is the D flip-flop, using the positive edge, you can uh, get the output of this flip-flop which was stored in a register. So is there any question so far?
No, sir.
Okay, so now suppose we are making a register that is called, that is used for serial data transfer, and that hence it is known as shift register. So how this shift register works, let us see. So now as you can see, for this flip-flop, the J is going directly getting the data input, and K is getting the data input after inverting that data. So whenever you have a JK flip-flop, and Q prime is the output. So whenever you have J and K, both have the inverted input, so this JK flip-flop will work as a D flip-flop, right?
Yes, sir.
Awesome. তুমি রেজিস্ট্রেশন না করলে রেজাল্ট পাবা কিভাবে? তো সেটাই তো বলতেছি, তুমি পরীক্ষা দিছিলা ঠিক মতো? পরীক্ষা দিলে তো রেজাল্ট না পাওয়ার কোনো কারণ দেখি না। আমার কাছে যে রেজাল্ট ছিল সব আমি স্যারকে পাঠাই দিছি, আনোলজি স্যারকে, ওনার সাথে যোগাযোগ করো। আনোলজি স্যারকে চিনো না? হ্যাঁ, ওনার সাথে যোগাযোগ করো। Okay, so now then this JK flip-flop will work as a D flip-flop, right? Similarly,
Yes, sir.
this flip-flop, as you can see, X3 is the output input for J, and X3 bar is the input for K. So this flip-flop will also work as a D flip-flop, right?
Yes, sir.
Flip-flop also, X2 is the input for J and X2 bar is the input for K. So this will work as a another flip-flop, and so it is the same thing for the last flip-flop D0. So now if you get the pulse, because the same pulse is given to each and every flip-flop, and as you can see from here, it is a negative edge triggered flip-flop, right? So we have
Yes, sir.
to consider only the negative edge. You got my point, right?
Yes, sir.
So now whenever you have the data in, so suppose before this pulse is provided to the flip-flop, if we consider D3 and the output was of the D3 is 0, so it will remain 0 until we get the first negative edge, right? So when we get the first negative edge, just before the negative edge, what is the value of the data input? 1, right?
Yes, sir.
When it gets the negative edge, it will switch to 1 and remain 1 until it gets the next negative edge. And just before this next negative edge, what is the value of input?
Sure.
0, right? So it will switch from 1 to 0 and remain in the 0 condition for until it the next negative edge. And now if you can see, what is the value of the in data input before the negative edge?
1.
So it will switch to 1 again, and it will remain 1 until it gets the next negative edge, and just before that negative edge, the data in is also 1, so it will remain 1 until it gets the next negative edge, right?
Yes, sir.
So what will be the value of the D? 0 0 1 0 1 1, right? So for D2, what is the value of, sorry, this is not D3, it should be what? X3, right? Because X3 is the output of D3, right? So now for the second flip-flop, what is the input?
X3.
X3, right? So now for as you know, for the D flip-flop, if it remains 0 before the pulse is provided, so it will continue on 0 until it gets the first
Negative.
and just before that first negative is, what is the value of X3?
0.
0. So it will continue to 0 until it gets the next negative edge. Just before the next negative edge, what is the value of X3?
1.
1. So it will switch to 1 and it will remain 1 until it gets the next negative edge. Just before the next negative edge, what is the value of
0, sir.
X3? That is 0. So it will switch to 0 and it will remain 0 until it gets the next negative
Negative.
edge. And just before the next negative edge, what is the value of?
1, sir.
So 1. So it will switch to 1 and it will remain 1 until it gets the next negative edge. So now what will happen here is that, so for that the third flip-flop, what is the input? X2, right? So it will always follow X2 as an input. So like the other inputs or outputs, if we consider it was previously on 0 state, so it will continue in the 0 state until it gets the first negative edge. And whenever you get the first negative edge, just before the negative edge, what was the value of X2?
0.
Right? So it will continue to be
0.
until it gets the next negative edge. And just before this next negative edge, what is the value of X2?
0, sir.
0. So it will continue to 0 until it gets the next negative edge. And just before the next negative edge, what is the value of
X2 is 1, sir.
1? So it will switch to 1 and it will remain 1 until it gets the next.
Negative.
And just before the next negative edge, what is the value of x2? 0. So it will and remain 0 until it gets the next negative edge. And likewise, for the last flip-flop, x1 is the input. So if we try to draw the x0 and consider that x0 was 0 before the pulse is applied, so it will continue to be 0 until it gets the first negative edge. And just before the first negative edge, as x0 is following x1, what was the value of x1?
0.
So it will continue to 0 until it gets the next negative edge. And just before the negative edge, what is the value of x1? 0, right?
Yes, sir.
So it will continue to 0 until it gets the next negative edge. And just before the next negative edge, what is the value of x?
0, sir.
0. So it will continue to 0 until it gets the last negative edge. And just before the last negative edge, what is the value of x1? 1. So it will switch to 1 and remain 1 until it gets the last value. So now, as you can see, what is the value of x3? x3 value was 0, 1, 0, 1, 1. That is the value of x3. So what is the value of x2? You can see 0, 0, 1, 0, 1. So it is 0, 0, 1, 0, 1. Sorry, let me write it like this. So 0, 0, 1, 0, 1. So as you can see, this 0 is switched here, shifted here, this 1 is shifted here, this 0 is shifted here, this 1 is shifted here, and since there is no negative edge, so it cannot shift further, right?
Yes, sir.
For the next x1, what is the value? 0, 0, 0, 1, 0. So we can write 0, 0, 0, 1, 0. So this 0 is in the next pulse, this 0 is shifted here, this 1 is shifted here, and this 0 is shifted here for x1, right?
Yes, sir.
Can you see that? And for the last one, 0, 0, 0, 0, 1. So 0, 0, 0, 0, 1. So what is happening here? This 0 is shifted here, this 0 is shifted here, this 1 is shifted here for x0, right? So whatever you are putting here, in each and every negative edge, it is shifted to the next flip-flop. You got my point, right?
Yes, sir.
So that's why it is called serial data transfer, because in serial data communication, what is happening? One bit is shifted at a time, right? Or one bit is transferred at a time. If it is a parallel transmission, like the previous case, then you will have so many channels, and the number of channels will be equal to the number of bits that you can transfer at a single time. So since there is a 3 channel, so how many bits you can transfer at a time?
3 bits.
But here
Only 1.
only 1 channel, so you can transfer 1 bit at a time. And as you put more and more negative edges, 1 bit will be shifted from one flip-flop to another one. You got my point, right? So here also, as you can see, in the next pulses, it shifted, right?
Yes.
So it shifted. And from here also, as you can see, it is shifting, right? So each and every pulse, the previous flip-flop is transferring what is obtained as input to the next stage. Is there any question so far? Is there any question?
No, sir.
Okay. So now what we are doing here is called parallel data in, serial data out, shift register. Parallel data means whatever data you give here, then what will happen? It will be shifted from left to right. So how many bits are here?
4 bits.
4 bits. So these 4 bits will be shifted from one to another
Once at
in 4 clock pulse. You got my point, right? So now let's see how it works. So suppose first here there is a control switch. It's called shift and load bar, meaning whenever you give 0 here, after not get, what will be the output? 1 here, 1 here, 1 here, and 1 here, right?
Yes, sir.
Since 0 is directly connected here, so this input will be 0, this input will be 0, this input will be 0. So if any input of a AND gate is 0, then the output of this AND gate would be,
Yes.
meaning this AND gate, this AND gate, and this AND gate, it will not work. So whichever will work. So whenever shift / load command is 0, then what will happen? G1, G2, G3, and G4 will be on, meaning whenever G1, G2, G3, G4 is 1, so since one of the input of G1, G2, G3, G4 is 1, then what will happen? Whatever you give as D0, D1, D2, D3, it will come as a output here, right? D0, D1, D2, and D3 will come as an input to this flip-flop. You got my point, right?
Yes, sir.
So then what will happen? D0, D1, D2, and D3 will be the input of the flip-flop. And as it gets the first pulse, negative, positive edge, then what will happen? Q0 will follow D0, Q1 will follow D1, Q2 will follow D2, and Q3 will follow D.
Yes, sir.
So here we can write, then my Q0 will follow D0, and Q1 will follow D1, Q2 will follow D2, and Q3 will follow D3, right? When my shift / load signal becomes 1, so what will happen then? So let's see what will happen then. So whenever what will happen now? Whenever you put 1 here, you put 1 here, so after NOT gate, this will be 0, this will be 0, this will be 0, and this will be 0, right? And since this is 1, so this will become 1, this will become 1, and this will become 1, right? So now since G1, G2, G3, and G4 has one input, that is 0, so output of this AND gate will be 0, right?
Yes, sir.
Meaning you cannot put from outside to inside of this flip-flop, right?
Yes, sir.
So what will happen now? So here you can see when this value is 1, what will happen? Q0 will come as an input for G5, right? And output of this flip-flop will be, AND gate will be Q0. So Q0 plus 0, it will give you input
Zero.
here, right?
Yes, sir.
Similarly, the output here will be Q1. So the input here will be Q1 and input here will be Q2. So input for this flip-flop will be Q2. So whenever you have this scenario that you have put 1 in the control command, then what will happen? G1, G2, G3 and G4 will be off, right?
Yes, sir.
And then what will happen? Q0 will be what? 0, right? Because no data is coming from here, right?
Yes, sir.
So Q0 will be 0 and then Q1 will be
Q0.
Q2 will be
Q1.
Q1 and Q3 will be Q2, right?
Yes, sir.
So you understand my operation, right? How it works. Any questions so far? Question?
No, sir.
So for now, let's see how it works then. So here suppose this 4-bit number is 1, 0, 1 and 0 that we need to transfer from left to right. So as you can see, these flip-flops, they are positive edge triggered, right? So we need to consider only the positive edge, not the negative edge, right?
Yes, sir.
So now what will happen? Suppose we are considering the value of Q0. So whenever you have Q0 and its value is 0, it will remain 0 until it gets the first positive edge, right? So just before the first positive edge, what is the value of shift and load command?
0, sir.
0. So whenever it's 0, it means what will happen? Whatever you give here, it will come as an input for the flip-flop, right?
Yes, sir.
So what is the value of this D0? So 1 would come here, 0 will come here, 1 will come here and 0 will come here. So what will be the value of then when it gets the first positive pulse? What is the value of Q0? It will
1.
1, right? So it will switch to 1 as it gets the first positive edge and just it will remain 1 until it gets the next positive edge, right? So before it gets the next positive edge, what is the value of shift and load command?
1. Yes, sir.
So whenever you have one command here, then this flip-flop will not work, right?
Yes, sir.
Said G1 will be
Turned off.
right. So if J1 is off, then what will happen? This input here will be 0, right?
Yes, sir.
So as you can see from here to the last, it is always 1, right? Meaning this AND gate will be off for the next of the pulses, right?
Yes, sir.
Is there any question so far? So now for if you draw the output for Q1, so now what will happen whenever this value is 0? Let me draw the pulse first. So let me draw it with another color. Okay. So if you consider Q1 was in the 0 state as well, so just before the first positive pulse, what is the value of shift and load command? 0, right?
Yes, sir.
So if it is 0, what will be the value of Q1? Q1 will follow 1, right? So
Yes,
what
sir.
was the value of D1?
0.
0, right? So it will continue to be 0 until it gets the next
Post.
edge, right? So sorry, positive edge. So whenever it gets the first positive edge, next positive edge, just before that, what is the value of this command? 1, right?
Yes, sir.
So when it is 1, what will be my Q1?
Q0.
Q0. So just before this pulse, what is the value of Q0?
0.
0 or 1? We are considering here, right? So just before this positive pulse, what is the value of Q0?
Oh, it's 1, sir.
1. So it will switch to 1 and remain 1 until
Next.
the next positive edge. And just before that, what is the value of this? Is also 1. So if this is 1, it will always follow Q.
Q0. Yes,
So
sir.
for the rest of the cycle, it will always follow Q0. So what is the value of Q0 here?
0.
So it will switch to 0 and remain 0. Then what is the value of Q0? It is again 0. Then what is the value of Q0? It is again 0. And then what is the value of Q0? Q0, it is again 0. So it will work like this, right?
Yes, sir.
Now, if you try to get the output for Q2, and we consider that Q2 is also 0. So here, when your shift and command value is 0, so what will be the Q2? It should be the D2, right? So what is the value of D2?
Q2.
D2 value is 1, right? So whenever you get 0, then what will be the value of Q2? Q2 will follow D2, right?
Yes,
So what
sir.
is the value of D2?
1.
1. So just it gets the positive edge, it will switch to 1, right?
Yes, sir.
It will continue 1 until it gets the next
Positive 8.
positive edge. And here, since the load and shift command is 1, so whenever is 1, for the rest of the cycle, it will always follow
Q2.
Q2 follow Q1, right?
Yes, sir. Q1, sir.
So just before this pulse, what is the value of Q1?
0.
0. So it will switch to 0. And before this positive pulse, what is the value of Q1?
1.
1. So it will switch to 1 and remain 1 until what is the value of Q1 here?
0, sir.
So it will switch to 0. What is the value of Q1 here? 0. So it will remain 0 until this pulse ends, right?
Yes, sir.
So now if we want to draw the waveform for the last pulse, that is my Q3. So what will happen to Q3? So now if we try to draw the output for Q3, and if you consider that it is 0 until this pulse is applied, so first when the positive edge is achieved, then this value is 0, meaning when this value is 0, what will be my Q3?
G2.
Q3 will follow D3. So what is the value of D3?
0.
0, right? So it will continue to be 0 until it gets the next positive edge. Now, when it gets the next positive edge, what is the value of this signal? 1.
Yes, sir.
Whenever it is 1, what should be my Q3?
Q2.
It will always follow Q2, right? So before this pass, what is the value of Q2?
1.
1. So it will shift to 1 and remain 1. What is the value of Q2 here?
0.
0. So it will shift to 0 and remain 0. What is the value of Q2 here?
1.
1. So it will shift to 1 and remain 1. Then what is the value of Q2 here?
0.
0. And it will remain 0. Then what is the value of Q2 here?
0.
Right?
Yes, sir.
So it will continue to be 0. Now, as you can see, from Q0 to Q1, this pulse is shifted, right?
Yes, sir.
Then this pulse is shifted here, and finally this pulse is shifted here, right?
Yes, exactly.
Now this pulse is also shifted here, and then this pulse is shifted here, right?
Yes, sir.
Now this pulse is also shifted here. So now if you can see the output, how it is working. So 0 1 0 1 0. So what was your value? 1 0 1 0, right?
5.
So 0 will go first, then 1, then 0, then 1. Then is there any bit here? So as you can see, the first bit was 0, which is this one. Then this one is this one, right? Which is shifted. And then this 0 is here. And finally this one is here. You got my point, right?
Yes, sir.
So whatever value you give here, it will be shifted from left to right. Is there any confusion? Is there any confusion?
No, sir.
Sorry, I made a mistake. Is that this first 0 is this one. Then in the second pulse, this one is this one. Then in the third pulse, this 0 is this one, and the last pulse, this one is this one. And since after that there is no 0 there, so then no input there, so that's why in the last pulse it is 0 here. So this one is from
First one.
D0, right? This 0 is from D1. This one is from D2. And this 0 is from D3. You got my point, right?
Yes, sir. Just the reverse size.
Yeah, so in the first pulse, whatever is D3, it will come as output. Then in the second pulse, this will come as output. And in the third pulse, this will come as output. And in the fourth pulse, it will come as output. And after that, there is no data. So you will see always 0 after 4 pulses. You got my point, right?
Yes, sir.
So if you understand everything, now let's see how these two serial transfer between two registers happens. So in the first, before the pulse, it is said the output of x2, x1 and x0 was 101. So it was like this, 101. So the output of this register would be 0, 0 and 0, right? So as you can see, this is serial transfer or parallel transfer,
It's serial transfer, sir.
because there is only one channel, right, for data
Yes, sir.
transfer.
Yes, sir.
So now, as you can see, the pulse that is given. So here, if we draw the pulse, suppose we are drawing 6 pulse. This is the pulse. Like this. So these are all negative edge triggered, right?
Yes, sir.
Negative edge triggered.
Sir, to see whether it's negative or positive edge trigger, we need to look at clock, no, sir? Oh,
Clock,
yes.
and if there is a bubble with it, it means it's a negative
Edge
edge
trigger.
triggered.
Yes.
And if there is no bubble, it means
Positive edge trigger.
it's a positive edge triggered. Okay.
Yes, sir.
So now, just before the clock pulse, first clock pulse is provided, here it says what would be the value of x2, x1 and x0. So if you draw x2, x1, x0, and then y2, y1 and y0, so just before the pulse, here let me cover up this whole thing. Okay, so it says just before this pulse, what is the value of x2? It was 1, right?
Yes, sir.
x1 is 0, x0 x0 is again 1, and y2, y1 and y0 is 0, right?
Yes, sir.
So now, after the first clock pulse, if it is 1, it will remain 1 until it gets the first negative edge, right?
Yes, sir.
And after that, you can see what is the input here?
0.
0. So it will switch to 0 and it will remain 0 until the next all the pulses, right? Because the input here is constantly 0, right?
Yes, sir.
So now x2 is the input for x1 and x1 will follow x2.
Yes, sir.
So x2 will follow x1. So just if it is 0, it will remain 0 until it gets the first edge, right?
Yes,
And
sir.
just before this negative edge, what is the value of x2?
1, sir.
1. So it will switch to 1 and it will remain 1 until it gets the next negative edge, right?
Yes, sir.
So what is the value of just before this negative edge? What is the value of
X2.
X2 0, right?
Yes, sir.
So it will switch to 0 and remain 0 until next negative is, what is the value of x0?
0, sir.
0, right?
Yes, sir.
So it will continue to be 0 for the next pulses, right?
Yes, sir.
Now x0 was previously 1, so it will continue to be 1 until it's the
First negative edge trigger.
first negative edge. So whenever it gets the first negative edge, just before the negative edge, for x0, what is the input of x0? X1, right?
Yes, sir.
So just before the negative edge, what is the value of x1?
0, sir.
0. So it will switch to 0 and continue to be 0 until it gets the
Negative
negative edge. And just before the negative edge, what is the value of x1?
1.
So it will switch to 1 and it will remain 1 until it gets the next negative edge. And just before the negative edge, what is the value of x1? 0.
Yes.
Switch to 0 and remain 0 until the rest of the pulses. You got my point, right?
Yes, sir.
So now for y2, what is the input? X0.
X0.
So y2 will always follow x0, right?
Yes, sir.
So now just before the positive edge, what is the value of y2? It was 0, so it will continue to be 0 until it gets the first negative edge. And since it is following x0, what is the value of x0 before that?
1.
So it will switch to 1 and remain 1 until it gets the next negative edge. What is the value of x0 here?
0.
0. So it will switch to 0 and it will continue to be 0 until it gets the next negative edge. What is the value of x0 here?
1, sir.
1. So it will switch to 1 again and it will continue to be 1 until it gets the next negative edge. What is the value of x0 here?
It will be 0 for
0. So it will switch to 0 and then continue to be 0 for the rest of the pulse. You got my point, right?
Yes, sir.
So now similarly y1 is following
Y2.
y2. So what will be the value of y2? Let me do it another color. So it will continue to be 0 and then before that, what is the value of y2 here?
0, sir.
0. So it will continue to be 0 here. What is the value of y2 here? 1.
1.
So it will switch to 1 and remain 1 until it gets the next negative edge. What is the value of y2 here?
0.
So it will switch to 0 and continue to be 0 until the next negative edge. What is the value of y2 here?
1.
1. So it will be 1 and it will continue to be 1 until the next negative edge. What is the value of y2 here?
0, sir.
0. So it will switch to 0 and continue to be 0 until the next negative edge, right?
Yes, sir.
So now for the last part, let me draw it with the red color. So it will continue to be 0. Now before that, what is the value of y1?
0.
So it will continue to be 0. What is the value of y1 here?
0.
0. So it will continue to be like this. And then what is the value of y1 here?
1, sir.
So it will switch to 1 and remain 1. Then again value is 0. So it will switch to 0 and then
Again 1.
again 1. So it will switch to 1 and then just before that, what is the value of
0, sir.
0? So it will switch to 0 and then it will do like this. So now if I draw the value for each and every pulse, so what will happen? So here you can see this was 1 0 1, then 0 0 0, right? Which was the before the pulse, right?
Yes, sir.
So after the first pulse, what is the value? 1
0, 1.
1
0.
0 0 0, right?
Yes, sir.
So what we can write? So for the first pulse, it will remain as it is 1 0 1, and then 0
0.
0, right? Then it should be the first pulse, right?
Yes.
First pulse is gone. And now in the second pulse, what is the value? 0 1 0 1 0 0, right?
Yes, sir.
So we can write 0 1 0 1
1 0
0 0, right?
Yes, sir.
Second pulse. So what is happening here?
Shifting, sir.
Every pulse is one
Getting.
position, right?
Yes, sir.
So what is the value for the next pulse?
You again shift.
0 0 1, then 0 1 0, right? So 0 1, then 0 1 0. This should be the third pulse, or third edge, we can say. So as you can see, this 3 bits is shifted
Right.
once more right?
Yes, sir.
So similar way, in the next pass, what is happening here? 0 0 0 1 0 1. So we can write 0 0 0 1 0 1. So as you can see, this thing is shifted once more in the fourth pulse, right?
Yes, sir.
Then in the next pulse, what is the value? 0 0 0 0 1 0.
0.
So 0 0 0 0 1 0. As you can see, since there is no space or no other flip-flop is here, so you can see only the 2 bits remaining, right, in the fifth pulse.
Yes, sir.
And in the last pulse, what is the value? 0
0
0 0 0 1. So 0 0 0 0 0 1. So as you can see, this bit is the last bit here remaining in the sixth pulse. So if you draw it for the next pulse, what will happen?
All 0, sir.
All will be 0 in the seventh,
7 pulse.
right?
Yes, sir.
Is there any confusion or anything that needs clarification? Oh, if it is no, then this is the end for today's class. Tomorrow we'll have another online class. I'll let you know the time. Okay.
Yes, sir.